Okay guys, I'm going to just try and do some short slides, maybe a video on just the basics behind metals, their properties, their uses, general knowledge really, but stuff that if you don't know and understand the basics, it makes it very, very hard to understand metals and engineering in general. So I suppose one of the first things you need to know is, where do metals come from? So metals are dug out of the ground. When the metal is mixed with all the dirt and rock and everything, it's called ore. The ore that's in front of us there, it's often called hematite, but that's the color of iron ore. And beside us there, you can see a silver ore, and that's what metal mixed with dirt and rock is called, and it's generally taken out of the ground and crushed up and put into a powder. Now, to extract the metal from the ore generally involves heat. So pyro metallurgy is using fire and heat. So I've just put on screen there is a picture of a very old blast furnace, and on the right here there we can see what a modern blast furnace looks like. You know, it's often maybe a 11 or 12 story building there. It's like a small town there, a modern blast furnace, like they're a massive operation, and that's for producing steel. The blast furnace is used to produce, well, pig iron that's then made into steel. It wouldn't be a furnace like that now for silvers and golds and all of those, but the principles are the same. Basically, you melt the ore and the metal and they separate there. Then often it's the metal is heavier and it'll sink to the bottom, and they can be separated that way. Now, some basic principles is that all metals are solid at room temperature except for one, which is mercury. So mercury stays liquid until it gets to minus 38 degrees C. So for, I don't know if anyone has experimented there with mercury inside in a science lab. For those of you that are old enough, you would, people my generation, your temperature would always have been taken with a thermometer which has mercury down here at the tip of it, and you could stick it in the tea if you got a chance there to drive up your temperature for a day off. But now with modern thermometers, it uses infrared or something like that for a digital reading. So all the other metals except for mercury have got a higher melting point. Mercury is the only one that's a liquid at normal room temperature. Now, in relation to colors then, okay, all metals are silvery grey in color except for two, copper and gold. Okay, there we see our copper pipes that everybody would have seen them at some stage. Copper wires and copper being used for the immersion in a hot tank or something like that. But in general, all of the other metals are silvery grey except for copper and gold. Now, another thing to know about metals is that metals conduct heat and electricity. So conduction there is when you stick the end of a steel bar or a metal into the fire like that, and the heat will travel along and back along it there. So even though back along here now is not inside in the fire, the heat will travel along it. And it's the same with electricity. Electricity will travel through metals as well. So that's why metals are a good conductor, and the best metals to conduct electricity would be silver and copper and gold, but gold is too expensive to use for it. Now another property of metals is they can be polished or they can take a shine. So just here in the very first picture there is stainless steel, which is often used for tanks like milk tanks and containers. In the second one there then we can see the bumpers there, which is chromium. So it's also used in Harley Davidson motorbikes and stuff like that, because chromium is very, very good to shine and take a polish. And finally there, gold and silver as well are famous for their use in jewellery because they shine and take a polish. Now metals are opaque, which means you can't shine a light through them or see through a metal. So glass here, first of all, is transparent, which means you can shine a light through it or see through it. Translucent is when you can't really see through it, but it would allow light through it. And the other extreme there then is opaque, which means you can't shine light through it and you can't see through it, and that is the property that metals have. Now metals are usually heavy. So when I say heavy metal, I'm not talking AC/DC here or Metallica or Guns N' Roses, but just in their density. Now, one of the heaviest metals is lead, okay, that's used in roofs and around chimneys to stop the water leaking in, because it's very easy to bend and shape it without breaking, and it doesn't rust. And the opposite then, I suppose, is a light metal would be aluminium, which is exceptionally light for a metal really, but most metals are heavy. Now, the next question is, how are metals categorized or laid out? So I suppose everything we do in society as humans, we categorize it like male or female or by nationality or height or whatever. Like there's ways of categorizing stuff to make it easier to talk about them. So for metals, there's generally three categories. There's ferrous metals, and ferrous metals are the ones that contain iron. So ferrous means they have iron. It's basically all the hundreds of types of steels and irons. Secondly then, there's non-ferrous metals, of which there is probably 90 something I would think, but it's like copper, gold, lead, silver, tungsten, loads of them. We'll be looking at them later on, and they're the non-ferrous, means that they don't have iron in them. So there's hundreds of kinds of steels, and then there's probably over 90 non-ferrous metals then which are not steels. And finally there is alloys. Now brass, okay, that's an alloy there. You'd always see them used for fitting pipes and stuff like that, but brass is a mixture of copper and zinc, and bronze then is a mixture of copper and tin. So it's from the copper is where it gets its color, but alloys don't exist from ore. Like you can't find brass ore and make brass. You find copper ore and zinc, and you can mix them together and make brass or bronze or and stuff like that. Solder, which is made from lead and tin. Now, from an engineering point of view, ferrous metals, of which I said there's hundreds, the name Fe is the symbol there on the periodic table for iron or for ferrite. So ferrous metals contain iron. So there's hundreds of kinds. Okay, so they're cheap and strong. They're used in construction and engineering, and they can be very different depending on how they're made. So you can make them to be hard or pretty soft, like a coat hanger, or springy for the springs in a car, or stiff or brittle, like a device in the metalwork room there. They're very strong. Well, they're cast iron, which is very high carbon, and if you hit them hard with a hammer, they would just crack. So steels are famous, I suppose, for rusting if they get wet, which is why we make stainless steel then, which is adding chromium to steel, which then it becomes an alloy, but it doesn't rust. So by adding metals like chromium, you can get steels that don't rust. The best known steels would be mild steel, high-speed steel that's used for drill bits and cutting blades and stuff like that, and stainless steel. Now non-ferrous metals, so non-ferrous means no iron. So there's around 95 of them. Non-ferrous metals are generally more expensive than steel. Some of them like uranium, platinum, palladium, lead or silver and gold are very, very expensive. They're used in the computer industry and for jewelry and stuff like that. So the best known: gold, silver, copper, lead, aluminium, mercury, zinc, platinum, tin, tungsten. So like all of those are non-ferrous, they don't have iron in them, so they generally don't rust. Now alloys are different to pure metals because gold, tin, copper, lead, mercury, iron, all of those are pure metals where you dig the ore out of the ground and you separate the metal from the ore and you have that pure metal. Whereas alloys have to be mixed by humans. So alloys are a mixture of two metals for the most part. Now, sometimes people get confused because carbon is used with iron to make steel, and carbon is not a metal, but for all intents and purposes, an alloy is two metals mixed together. So people get confused there because earlier on we said that all metals are silvery grey in colour except for two, which was gold and copper. But then you take brass, which wasn't on that list, or bronze, and that's because they're not pure metals. Even though they are silvery or they're goldy in colour, they get their gold from the copper that's in them. So an alloy is two metals mixed together. Now, some of the best, I'm going to look at 6 here, but brass is made by mixing copper and zinc. And like brass is made is used for door handles or hinges and stuff like that. Now bronze is made then from copper and tin. So bronze is a darker shade, much darker shade than brass, and bronze is used for Olympic medals very famously, but for statues really, because it's very liquidy, watery, and it takes the shape really well of a mold. Now the third alloy then we'll look at there is solder, which is used in the electronics industry a lot for joining wires, but it's also used by plumbers for joining pipes. So that's one that wouldn't be known quite as well. Now high-speed steel is an alloy, and that's steel mixed with tungsten. Now high-speed steel is used for making drill bits and taps for cutting threads and anything there that involves cutting really, where it's quite hard and it holds its edge. Now the fifth one we'll look at there then is stainless steel, which is steel mixed with chromium. Now for all the lads, you'll be familiar with seeing urinals are made from stainless steel, but cutlery, knives and forks is another one that's always made from stainless steel. And the last one we'll just look at here is aircraft aluminium, which is an alloy of aluminium and zinc. So you mix aluminium and zinc, and the reason that a lot of aluminium alloy is used in aircrafts is because it's quite light compared to steel. so it's strong for its weight, and that's why aluminium is used a lot in the aircraft industry. So yeah, brass, bronze, solder, high-speed steel, stainless steel, and aluminium alloy, they're all mixtures of metals to get a better metal, a metal that doesn't rust, or a metal that's shiny or looks good. That's why alloys are created, or that have a low melting point or a high melting point. You can combine the metals to get a better metal. Now, a few of the metals that are used very commonly in engineering, we're going to have a look at them, starting with aluminium. Now, aluminium, it's got that silvery grey colour that everybody would be familiar with. It's very well known for being light and strong. So in the pictures over on the side there, you can see ladders. Light, no bother to lift them up and down on the roof of a van or carry them around the place. And for bicycles as well, they're light and strong. The lighter the better. Now, professional cyclists use carbon fiber, which would be lighter again, but it's a lot more expensive. And it does not rust. And that's another great thing about bicycles and ladders and stuff that are used outdoors. The fact that like iron and steel rust when they get wet, aluminium does not. Now, aluminium is cheap because it's a very, very common element, so there's no bother finding it. It's not like trying to find gold or uranium that are difficult to find. And that is why it's cheap, because it's common. Now, it's a great metal to recycle. Some of the stuff that it gets used for over there on the side as well is for food trays and canned food like tuna, beans and sardines and all that. Cans of Coke and things like that. And what used to be years ago called tin foil is now alu foil or cooking foil. And increasingly it's used in car bodies and stuff as well, because aluminium alloy is strong and light, and with the increased use of electric vehicles, manufacturers are trying to keep the weight of the car down. And another good thing about it is that it's safe around food, and that it doesn't react to the food or, you know, rust from being wet or anything like that. So that's aluminium and some of the things that it's used for. Now, finally, copper. Just a quick look at copper and its properties. So, very well known for conducting heat, which is why it's used in water heating tanks, and conducting electricity, why it's used for wires. Copper does not rust, and it's used in brass and bronze. It's cheap. It's soft and malleable, which means it's easy to shape it. So that's one of the uses of copper there, in the form of bronze when it's mixed with tin. So copper and tin is used for that. Used for bracelets, copper wiring and electricity. Famously for the bronze medal in the Olympics if you finish third. And just a few of the other uses there is for pots and pans traditionally, water pipes. There we see it in electronic circuits, in a brass valve shut off there. You can see it, copper being used for a copper tank and for a heating coil inside in the copper tank, and in a copper inside in a motor as well there. So there are some of the many uses of copper.